Okay, so in this video we are going to talk about logarithms, and this is actually the video that I said would involve some math, but don't be too scared, it's not going to be that big of a deal. Now, logs, as you might have expected, are not so straightforward of a complexity like, say, constant time, big of 1, or linear time. It's a little more complicated than that. And the reason that we talk about logarithms at all is because some algorithms, some known algorithms actually, have a complexity of logs. They involve logs. So some algorithms have a complexity of log of n, some algorithms have a complexity of n log of n, and so on. So having a log in your complexity is something, I wouldn't say that is common, but it is somewhat common. So it's essential that you would understand the concept of logs and what do they represent. First thing, let's talk about what is a log. Now, for me, best thing about breaking the ice with logs, or the best way, is to actually see an example of logs and just see the result, find out how we actually derive that result, then figuring out what does log actually represent, and coming back to our example to see if what it represents actually is the answer. So you'll get it, but let's just now start with seeing this example. So here we got log to the base of 2. So here you can see the number 2. That's called the base of a log. So here the log is of base 2. And we're trying to find log of 16. And you can see here that the answer that we said log of 16 is actually 4. But how did we actually get that value? Well, you might have noticed that 2, which is the base of the log, to the power of that value, the one that we derived, is actually equal to the value of the log that we're trying to find. So 16, we're trying to find log of 16. And the log is to the base of 2. If we took that 2, and we took the result that we came up with, and had the 2 be to the power of 4, we would actually find that 2 to the power of 4, the base to the power of the value, is actually equal to the value that we are just wanting to find the log of. So 2 to the power of the exponent is actually equal to the value. And one thing that you should know is that we ignore the base 2 of the logs. So from now on, when I say log of 16 or whatever, you know that I'm talking about log to the base of 2, because there's logs to the base of pretty much anything. So, but in computer science, we mainly focus on log to the base of 2. But so what does a logarithm actually represent? What is it that we just saw, this 2 to the power of exponent equal value and so on? Well, a logarithm, put in English format, is simply the number of times that you can divide some number by the log space before you get a value that's less than or equal to 1. So let's get back to our example where we saw the 16. Basically, we're asking ourselves this question: how many operations of division by 2, which was the base of our log, are we going to do on our value, the 16, before we reach the number 1? So here, we divided 16 by 2. We got 8. Then we divided 8 by 2. We got 4. Then we divided 4 by 2. We got 2. Then we divided 2 by 2, and that would give us 1. So here, the number of operations of division are actually 4, which is our answer, which is the log of 16. So one thing to know when doing complexity is that log of n is better than n, as you might have guessed, because judging from this slide over here, That means that, say our input was 16, it would take us 4 operations to reach the end of our algorithm. But in linear time, it would take us 16 operations, or whatever number. It doesn't have to be 16, it just has to be linear with 16. So log of n is better than n, of course. Also, n log of n is better than n squared for the exact same reasons. Because log of n is better than n, so n log of n is better than n multiplied by n, which is n squared. But n log of n is worse than n, also as expected. No multiplication is better than a multiplication. So what are some examples of algorithms that have some complexity that involves slugs? Well, maybe the most popular one is binary search. It's famous for having an algorithm of log of n, which is amazing. That's why binary search is arguably the most popular search algorithm out there. Another example is merge sort, which is an extremely popular sorting algorithm that is also used in tons of applications. It's a recursive algorithm and it have a complexity of n multiplied by log of n.